Okay, so in this lesson, I want to continue and try to have a little bit of fun here and see if we can start modifying the actual SDL surface that's part of our window. So the goal of this is going to be able to click in a particular position and modify those pixels. I'm going to do a little bit of exploring just so you can see how, again, I learned the API. I don't have anything prepared for this, so you're just going to have to watch and learn from me. So let's go ahead and begin and see where this leads us. So I know I want to capture some sort of SDL event here for our mouse clicks. We've been able to handle mouse motion and keys down and some of these other things here. In fact, I'm actually just going to get rid of these as they've been left over from our other tutorials in this series. So I know I want some event. And the type of event I want is to handle some sort of mouse button event here, which I see. So I'm going to go ahead and click on this and the particular button that has changed or been pressed. And it looks like going through the remarks here that there is a SDL button up or down that we can report from. And one of the attributes of the events could be a left mouse click. So let's go ahead and handle that. So it was an event button that brought us to our mouse event. And then the state that has changed here is another button. And we want to test against the left mouse button here. SDL button left. And let's just go ahead and put a little debug here so that we can see what happened. Left mouse was pressed, and I'll put an end line there. And let's go ahead and save and compile. So at this point, if I run our program, and I'll bring it down here, I'm right clicking, nothing, left clicking, looks like this is good. So again, this is how we can learn the API, just exploring and testing very, very simple small ideas and seeing how they work. Now, the second part of our mission is to figure out how can we modify our surface. We've been able to retrieve the surface from the get window surface in a previous lesson here. And we've been able to update that surface by calling SDL update window surface. So to me, this looks like something where I can modify the pixels and maybe I need to update it. Okay, so let's go ahead and roll with that idea and see what happens. There may be some other specifics that we want to test out. So what I'm going to do is go into the documentation here, and I've already opened up a few tabs behind the scenes for surfaces, which we've had from before. And I do notice that there is this sort of lock surface, and this appears to make things faster, at least when editing surface pixels on the CPU. And I've actually seen this on other APIs, so this looks like something reasonable to do. As we're modifying pixels, we lock that surface, perform our edits, and then we unlock that surface. That seems like something that can go in our mouse click routine where we want to do some updates. So let's go ahead and modify this. And we'll do SDL lock surface. And the surface that we're editing is our screen. And we must also unlock the surface, perhaps so it can do some edits or any optimizations otherwise behind the scenes. Okay, so let's go ahead and try this and see if it breaks anything if we're just unlocking and locking that main surface for our window. And if I bring this back in, I'm still able to handle events, so this looks good. Okay, so the next thing I need to figure out is how do I actually modify the pixels? Well, I can actually see as part of this sample as well that I'm able to retrieve the pixels from our surface here, whatever it happens to be, and then I can modify them. In this example, they're just setting them to different color. So let's go ahead and just play around with this example here and see if we can just change all the pixels to a different color here. So I'll go ahead and try this. And 0 being the byte value, what if I try 255? This should make all the pixels then turn white. So I'll recompile, and our surface isn't named surface, it's called screen. And we're able to do the pitch as well. So now let's try to recompile. Oops, and one more attribute to edit for the height. And we'll go ahead and try. And I'm going to bring my window in here. I'm going to click once and no updates here. Seems not to be working. I wonder if specifically for the window if we have to update the surface here. So let's go ahead and try this. Again, I don't have anything prepared, so we're just going to play around with this until we figure it out here. So it would seem like as soon as we make an update, it would be appropriate to update the surface. And in a way, this sort of makes sense. It would mean that we are sort of refreshing our screen every time we call this routine. In some engines, if you've used, this is the idea of sort of flipping your buffer. So you make modifications to the color, and then when those modifications have been finished on whatever surface that you're drawing to, then you flip to the newly updated surface, and then you can make modifications in the background. This is sort of a double buffering strategy. So let's again go ahead and try this and see if we're able to make any progress. And I'll try to rerun, bring in our window, click, and this seems to be good. So this is pretty cool that we can do this, but we probably want a little bit more precision. And we probably want to be a little bit careful too with how we're doing updates. So let's go ahead and take a look at this program and see what we can do. So I'll go ahead and disappear here. And I just want to, for a moment, for those watching on smaller screens, make this a little bit bigger just for a moment so you can see all of the code that's been present here. And I can go ahead and take this from the top as well and scroll through. Again, we created our surface, we have our window, we've initialized SDL, and we've created the 640 by 480 window. We have our screen, and we're doing our updates here. Now, the important part of this is that we have a 640 by 480 window. Now, why am I highlighting that? And it's nice that we did the review here, is because when we make our pixel updates, we're going to want to be able to get the mouse position and make sure that we don't draw outside of that 640 by 480 boundary. Otherwise, since that's outside of our surface, we might get a segmentation fault. Okay, so the question now is, how can I then get my window position, meaning my mouse cursor? Well, I'm going to go ahead and look through the input a little bit and try to figure out where this is. And there might be some related functions here in our mouse. So let's go ahead and we can see. Get mouse state or get relative mouse state. These are two that I probably want to open up. So get relative mouse state looks like it gives us a position. And get mouse state also looks like it's going to return the X and the Y coordinates of our mouse. Okay, in the window that we're focused on. So let's go ahead and try this. And there's a nice little example here. And it looks like this happens within our actual event loop here, which is, this is a related function to where we're doing our event-driven program. So let's go ahead and just create these variables here. I'm going to go ahead and do this within our event loop. Or actually, let's go ahead and do it just outside. Here, we'll retrieve the mouse state, and I'll create an X and a Y. And let's go ahead and follow their setup here. And we'll set buttons equal to SDL, get mouse state, and X and Y. Okay, let's try to compile this much and just see what's going on. So far, so good. And now instead of just printing out that the left mouse button was pressed, let's see if we can actually print the coordinates. So instead of putting an end line here, I'm going to go ahead and add in X and a space, Y, and terminate our string here, or our stream rather. Okay, let's go ahead and try to recompile, rerun, and I'll bring in our program, and we'll click around, and this seems reasonable. And this also looks like it's bounded. So if I click outside of the program or try to hold or break it, it's not going to go above that 640 by 480 range, which is useful. Okay, so I think the trick here now is going to be, how do I use this SDL memset function, which is literally changing the memory in a location to change a single pixel color. So let's go ahead and play around with this and see what happens. So this seems to be the key. And in this case, I'm actually going to write a little helper function here to set a pixel color. So let's go ahead and do that over here at the top of our program. And this is just going to be a void function, and we're just going to call it SetPixel. We know we're going to want to do this at a X and a Y position. And perhaps we want to change a particular red, green, and a blue value here. Now, a little aside in this tutorial series, I'm being a little bit wasteful here. Ints for the X position, when we know that they should be unsigned. The red, green, and blue positions have values usually between 0 and 255. That's okay. I just want to get something working, and then I'll optimize in a little bit. Or I'll leave that as an exercise for the reader to make these uint 8s. In fact, it's bothering me enough that I will just go ahead and show you how to do that. Uint 8 t, like the following. Okay, now we have our type system. That's going to help us here. And I'm being a little bit better of a programmer. Okay, so with that said here, let's go ahead and just live with this much here. Uint 8t. There we go. And these ones I'm just going to leave alone for the sake of moving us forward. Okay, so since we're setting a pixel here, one of the things that we probably also want to not worry about is locking our surface every time. So I'm going to generalize this routine a little bit, and that we're going to have an SDL surface, and we'll pass in that pointer to whatever the surface is. The reason I'm doing this again is because I really want to abstract all of this portion here. So let's go ahead and move this up here. And I'm even going to make this routine a little bit more specific in that we're working on a specific surface on our window. So let's just go ahead and abstract this a little bit more. And I'll just move all of this code here. Because what it appears to me is that this update window surface where we're doing the actual flip could belong in this function. Actually, I've changed my mind, and this is why you get to see me do the live coding. I actually just want to update the surface every time in our program. So this is happening in our main loop. So it'll just be constantly updating. Again, this may not be efficient, but that's okay. We don't need to be efficient quite right now. So we have, instead of our screen, this will be the surface. And we will want to unlock it, and so on. Okay, so now the question is, how do we set one of these pixels? And recall that within a pixel, we're setting the R, G, and B values. So let me go ahead and bring up our diagram here where we're going to draw. And recall that a single pixel has a red, green, and blue component. So we need to figure out what the correct offset is in memory. If it's helpful, you can think of this whole row here as being sort of side by side, meaning that we have a red value, a green value, a blue value, and so on. And the next red value, green value, blue value, and so on. So if I label these positions here, this is what we're really getting. And remember, the pitch is the length of this whole row at the top here. So that's how far across we're going. And that tells us when we're going to jump down to the next row. Okay, so with that in mind, let's go ahead and think about this problem out loud here. So I'm going to be setting a particular piece of memory here for our screen pixels. Now, if this is just giving me a pointer here to the actual screen pixels, I should just be able to change that value. And essentially what memset is doing is a quick way to fill the whole image. So let's go ahead and use what we have here and screen pixels. And let's go ahead and see what that data type is in the documentation for SDL Surface, which I might have open here. Here we are. SDL Surface gives us the pixels just as a void pointer. And this could be a little bit tricky because likely this could be any sort of data type, or it could actually vary because of if we have a red, green, blue, and an alpha component. So it could vary depending on what we change here. So if I get the actual pixels here, a pointer to them, for example, and let's do a void star pixels. Let's see if we can work with this much so far. And maybe the thing to do would be to actually try to figure out if we can modify our pixels. And what we would want to do is, for our particular surface here, is figure out where our y value is times the actual number of components we have plus the x. Again, if we just have 3 for the red, green, and blue, this should modify. But let's take a look at SDL pixel format here. and see if we can get how many bits per pixel here, or bytes per pixel. And it looks like that we can. This would be time, screen, and this is the format, and the bytes per pixel. Bytes per pixel. And let's go ahead and see if this works here. I'm just going to set it to one of our components here and see if this works. So this would be, or this should be rather the, well, we don't need this pointer if we're able to directly access our pixels. And that would be one other thing to check on here. It looks like this is read and write access, so we should be able to directly modify the pixels here. We want to be a little bit careful here. It looks like some things are only read only. So again, if you put on your programmer hats, this means that they're probably marked as const somewhere in the code. Okay, so let's go ahead and properly rename these surface because I've done the abstraction. And let's see if this works here. Pixels was not declared, and that's because this is, again, the screen pixels array that we are directly accessing. And once again, I will continue to make that mistake here, that this is the surface. Let me just work through these one at a time. Bytes per pixel, again, is a, it is a field, but this is of a pointer, so we need to access it appropriately. Now, we've got some errors here, and I suspect that this has to do with the warning here that it's a pointer of type void star. If I'm dereferencing void star and I don't have a type, meaning it doesn't know how to sort of break this down in elements here, we might run into some problems here. So let's go ahead and see if we can cast this. Otherwise, we may need to break this down in another step here. Let's see if our compiler will be able to treat this as, say, a uint 8, for example. So let's go ahead and see if we can cast the pointer type, and not quite. Let's go ahead and just break this down into a little bit simpler as I was doing here. So let's just go ahead and retrieve our pixel array here. I'm going to make this a uint 8 t for unsigned int type, and it might have been giving us some errors there. And let's just go ahead and name this pixel array, and let's just modify the pixel array. And let's go ahead and try that. And for the millionth time, screen will be known as surface in this abstracted function here. And once again, it's going to complain about this void star because we really need to say, hey, when we retrieve this, treat it as a uint 8 t pointer, not a void star pointer. Okay, so this looks pretty good here. Let's go ahead and try and run this and just see what happens. And actually, we need to make our function call. So before we do that, let's go ahead and make sure that we call this at least once. So let's see. Let's go ahead and just call this SetPixel because it's been generalized. I'm going to copy this function down a little bit here. And we know that we're handling our button events. We are retrieving an X and a Y position. So let's populate those. The surface, that is a pointer. This I can finally type out screen. It takes in the X position and the Y position. And let's go ahead and make our pixels 0, 0, 0. Well, in fact, since we're only modifying the red component for now, I'll just make this 255, and then we'll go back and fix that if this works. And one extra curly brace to remove, and a semicolon. All right, let's go ahead and give this a try. Run our program, and let's see if anything interesting happens when I click around. Well, something interesting is happening, but it looks like our arithmetic's just not working properly. So this is the fun part of graphics where we get to debug some of the graphical errors. So let's go ahead and look at our function and make sure that we're putting in the right offsets. Okay, so I'm going to go ahead and terminate this and scroll us up. And let's go ahead and see what we're doing. So I like this part where we're locking the surface. Our mouse button is being pressed, so we're able to record that. And now let's just think about our offset here. Now, where we could be getting into trouble is where we're figuring out what this bytes per pixel is. So y is the height of our image, or rather y is modifying in our diagram the row that we want to modify, and x is the position across here. So it looks like I've actually just made a mistake here where the bytes per pixel is probably some value like 3 or 4, which we could output. But I really want to be able to, if y, for instance, is 1, be able to move down this entire row here. So that's where I need to use the pitch field here. That's the length of the entire row in bytes, which will take into account this bytes per pixel. So let's go ahead and do y times the surface pitch. And then x is going to be the offset for that pixel. If it's a red value, we'll offset by 0 or nothing. If it's a green value, then that would be the next 8 bits or 1 byte. And if it's green value, we'll move 1 over. All right, let's try this. Red, green, and let's make this a lowercase b. In our SetPixel function, let's try to rerun and modify our surface. So now if I click, I'm getting closer. And I'm still getting some kind of funky or interesting colors here. So let's just take another look. So I'll go ahead and close this. We are getting closer. All right, so let me give us a clean slate here. And again, back to our diagram, we have our sort of setting here where we have the row that I think is set up, but the X offset is still off because when we shift over one position here in our X coordinate, well, we're also needing to move over a certain amount of bytes. So this is where we're going to actually multiply, let me go back up here, by the number of bytes per pixel here. So I'm going to do times our surface. And if I go back to our documentation, the format, and within format, again, the bytes per pixel. So let's go ahead and give this a try. Bytes per pixel, which we've already seen. And let's try this again and see if we get a little bit closer. For our surface, format, bytes per pixel. And once again, the surface, format, bytes per pixel. And recompile, rerun, and let's see what happens here. All right, now we're getting some blue here, but blue, again, may not be the proper color. So in order to fix this, we'll probably need to look at the format. The reality is we often think of color, or most folks learn color as red, green, blue format. But the reality is BGR might be another common format for blue, green, red. So one easy way to fix this is to just change our actual components here to match the format. We could query for the format here, but I want to go ahead and cut this video off sooner than later. So I'm going to take the somewhat easy way out here and just color this as the our API rather will take in red, green, and blue, but we will assume this is in BGR format. So let's go ahead and see if that gets us our red pixels on our screen. When I rerun, we get red here. And just to be sure, let's go ahead and modify our input function for the mouse. And if I do a right click, let's try a different color just to make sure that our assumption matches here. Let me go ahead and just copy this, do a paste here. And if the button is the right mouse button, let's do a green color and test our assumption that this is in a blue, green, red color format. Left click, and the right click does not appear to be drawing. or at least not as smoothly here. It's not detecting the down, but it is giving a blue color here. So it looks like it's actually in red, blue, green format here. Interesting. So let's go ahead and close this down here and swap our values appropriately. And it's in GBR format. And I'll rerun. And let's try this again. And we've got green, and we've got red. And we could add the middle mouse button for blue. So let me go ahead and leave this up here and speak to you for a moment. So as you could see, this was sort of an exploration video. I hope it was useful so you could see the surface and how it works and how we can modify it manually by locking it. We've also covered how to write a little helper function to set the pixel here. That could be interesting. And we've gone through our main, seen the screen here, how we create the window, having our game running, and again, some mouse events that we haven't previously seen. So I'm going to go ahead and minimize this just a little bit on the fonts just so you can see everything. And of course, this code will be available on the repository if you want. Now, I will say one of the fundamental things to keep in mind is how the different formats work in the image layouts. Again, the idea of pitch being the number of bytes times the width of the row and how to move through it, and how we access those, or in other words, we move down a row by doing the Y, where we currently want to draw, times that pitch, which essentially moves us down each one of these rows. And to position ourselves within a certain cell, such as here, the offset is the X position times how many bytes we need to move over. And then within that pixel, we modify the red, green, and blue pixel. And keeping in mind that red, green, and blue may not be the format. It might be something like GBR, or BGR, or RGB, or some other combination. It's not that uncommon in multimedia applications to have that mixed up. All right, so I'll leave it here. Please let me know if you enjoyed this format of exploratory videos and learning as I learn, and we'll see you in the next one.